that cost is associated with the high precision. The way this is used most frequently is a technique called real-time kinematic. The real-time means you're getting your precise position right away. It's being sent, there's some sort of radio connection or cellular or internet connection sending your correction. The kinematic is a word, of course, it basically means your robot can move around and get in the correct position, at every second, wherever you're moving the thing. And it also implies high precision. Kinematic GPS surveys means you're doing if you talked about the carrier phase, the different kinds of the signals you can use, like these handheld receivers are probably doing just a code solution, good to maybe 10, 20 feet, 30 feet. This is doing the carrier phase solution that's good down to a centimeter or two generally. Not always, but so a kinematic survey is going to be, your carrier phase. I'd set up over this thing, this point, and I'm using kinematic also implies you're getting a correction from somewhere. A single receiver GPS is really not that good kind of thing. Maybe you have a car, the handhelds, a couple tens of feet, if you don't have a lot of obstructions. With a correction, say from a single base station, that's what I'm using, the City of Madison's base station. It's basically able to cancel out a lot of the errors that the 20,000 kilometers that this signal is traveling, through the ionosphere and everything. All those errors are going to be pretty much the same here. Cancel out a lot of those errors. Get a correct position relative to the base station. So I've got the coordinates of the base station, and then I loaded the coordinates of this point that are supposed to be in the same coordinate system. And if so you can come up and take a look at this. And well, let's wait just a minute. It's saying I'm within about 0.06 of a foot north, so about 3/4 of an inch, 2/100 of a foot west, and then I'm within 0.06 of a foot elevation, which is really pretty amazing. The base station's down on Fish Hatchery Road and the Beltline over at the city, so that's a good couple of miles away. And if we got all the datum problems worked out, we're supposed to be on the same datum. That this thing can give you positions that accurate, that far away from the base station. So. If you have any questions too, jump in. Generally they say RTK GPS, the accuracies to about, in the literature you'll see the horizontal is good to a centimeter, plus or minus, or plus a part per million. So your accuracy degrades as you get farther from the base station. But if you've looked at statistical probabilities and that sort of thing, and bell curves, the centimeter is RMS, or about 1 standard deviation. So if you want to talk about like a 95% confidence, then you're up to 2 centimeters plus 2 parts per million, for 95%. And then that's for your horizontal. For your vertical accuracy, it's generally about twice as bad. So there are a lot of things that RTK GPS can do, but generally it's not wise to, say, stake out a parking lot with it. Or, at least for the horizontal, you're fine. You don't really care if your curve's a little here or there. The vertical, if you've got, like 0.3% grade on some curve and you want to make sure it drains, you shoot one point right. If you're 1/10 of a foot off, 20 feet away, all of a sudden the thing doesn't drain in the right direction. So, they're generally, RTK GPS is not used for applications where you need high relative precision in a small area. Then you should be using a level, just a good old-fashioned differential level is your best bet, and then a total station. The total station is calibrated and has all the compensation mechanisms where it can really give you good elevation. So what I use it for is mostly for setting control for my topographic survey projects. I'll set a bunch of control points, but I'll also shoot those all with the total station and use those more accurate, relative accurate measurements to adjust everything and get it all, improve the relative. It's used in all kinds of applications when airplanes fly, aerial photography. There's RTK GPS in the plane. When they fly LiDAR, it's sort of, or scanning. If you've heard about scanning at all, you set up an instrument and just get millions of XYZ coordinates. They'll even put those on vans and run them down railroad tracks and just do 10 miles of topographic survey. Well, it's got RTK GPS on it. But it also has other devices, because your RTK GPS second to second is as accurate as the scan shots are. So they have gyroscopes or inertial systems in there to tighten up the relative accuracy. I don't know how accurate we are relative to yours, because you're off in a different coordinate system. But
The other one that you see from that one is called submeters. That the ideal case is submeter resolution.
Yeah.
Versus this one is 1 centimeters. The
What are
price for this one is 2,000. This one is 20.
20, yeah.
Yeah, but he
20,
can give you
25.
cheaper.
Yeah.
Become 500 if you can.
Right.
I'm joking about that part. So your questions?
Yeah. Does anyone have any questions?
Yes.
Would you benefit from a base station that was up on top of space science?
Yeah, the city
in
has
terms
its
of-
own, and really
In terms of Z elevation?
huh?
In terms of Z accuracy, would that give you anything?
A lot of that is the call it a constant error, but the big chunk of that error is largely independent of how far you are from the base station. It does get worse. It depends on if you have a receiver that does dual frequency, L1, L2. Those you can get farther from the base station with less accuracy versus a single frequency. But yeah, the city's base is good, and you may have also heard of WSCORS. That's the Department of Transportation's statewide GPS base station network. So, people used to get into problems when they were 30, 40 miles away from a base station. The assumption that the errors at the base and at the rover isn't so good anymore. But the state has developed a network of base stations around the state, and they basically model all of the errors that you can get in your GPS solution. And so you can be out in the middle of nowhere and be using a solution basically from a couple of base stations, and it basically takes the part per million off of your error for that. The accuracy.
Question.
Yeah.
Does the city hire the young engineer? They are looking for the job.
Yeah.
Here we go.
I mean, people stay with the city as long as they can. Most of the city's engineering work is traffic engineering, street reconstruction, sewer plans, that sort of thing. So,
Water. Yeah.
yeah.
Water related
Water
to-
utility.
Yep.
There's some UW grads
Yeah.
with the water utility. Yep.